In this video, I'm going to go over a procedure that you can use to solve a nonlinear inequality. So this is different than solving a linear inequality where the degree is, say, 1. So here we're going to start off with a second degree. You got x squared minus x less than or equal to 6. Okay, so if I make this just an equal, then you've got a polynomial equation, quadratic equation. But it's an inequality. Less than or equal, could be greater than or equal, could be just less than, it could be greater. The procedure is the same. So what we're going to do is make, say, the right, doesn't matter which side, but one side has to be 0. So typically we select the right side to be 0. So I add -6 to both sides. That'll cancel this 6 over here and put it on the other side when I add the -6. And I get x squared minus x minus 6 is less than or equal to 0. Okay, now what I want to do is now find the numbers that make the left side 0. And the best way to do that is to factor it. So in the next step, I factor this. I get x minus 3 times x plus 2 is less than or equal to 0. Now, look at the left side. Now that I have it factored out, I want to find the numbers that make the left side 0. Okay, so the left side will be 0 when either one of those factors is 0. So notice x minus 3 is going to be 0 when x is 3. 3 minus 3 is 0. 0 times anything is 0. The second factor, x plus 2, is 0 when x is equal to -2. Okay, -2 plus 2 is 0. 0 times anything is 0. So we take the 3 and the -2 and we plot them in on a number line. Okay, in order of size, from smaller to largest. Okay, so first we have the number line, and then we plot the -2 and the 3. Okay, so this divides the number line into 3 intervals. Okay, so now what I want to do is find the sign of the left side on each of these intervals. Okay, so I pick a number slightly larger than 3. So to the right of 3, and then numbers between -2 and 3, and then numbers less than -2. Okay, so all I have to do is pick one number. I could pick 3.1, okay, because I've got all the way to the right. Okay, I'm going to pick 4. So pick a 4, put it where the x is in the parentheses. 4 minus 3 is positive. 4 and 2 is positive. A positive times a positive is a positive. So that would tell me then that to the right of 3, this expression here is positive. Okay, so we're trying to solve. Okay, so we want to find numbers that make this expression, this left side, negative. Okay, so now we pick a number between -2 and 3. Now, it doesn't matter what number you pick. Okay, it doesn't matter what number you pick because the sign is still going to be the same. And all we want to know is what the sign is. Is it positive or is it negative? So in here, I pick any number between -2 and 3. Okay, I'm going to pick 0. You could pick a 1. You could pick -1. I'll pick 0. I'll put a 0 where the x is. This factor would be -3. This factor would be 2. A -3 times a +2 is a negative. So in here, regardless of what number I pick, everything will be negative. So I just put a negative sign. Now if I pick a number less than -2, okay, I can pick -2.1. I'll stay with the integers, so I'm going to pick -3. Put a -3 where the x is. -3 minus 3, that's a negative. -3 and 2, that's a negative. A negative times a negative. So if I pick any number in here, I'm going to get positive. Okay, well, your solution is on the number line. What do I need? Okay, what am I solving? I'm solving this, but to make it easier, we're going to look at this right here, or this right here. So we want to find numbers where this expression is negative. Okay, if I pick a number over here, that's positive. If I pick a number over here, that's positive. So the solution is going to be between -2 and 3. -2 and 3. So that means that the solution to the original equation is any number that lies between -2 and 3. That is, x is greater than negative 2 and less than 3. And because I have an equals here, notice here I have less than or equal on these. The negative 2 and the 3 are also included, because if I put a negative 2 here and a negative 2 here, I get 6, and 6 is less than or equal to 6. That's satisfied. If I put a 3 here, where the x is, 3 squared is 9 minus 3. That's 9 minus 3 is 6. 6 is less than or equal to 6. So negative 2 is a solution, 3 is a solution, and because all the numbers in between make it negative, that means they're going to satisfy this inequality, and of course it'll also satisfy the original one. Okay, so the solution set can be written in interval notation. Interval notation is written this bracket and then negative 2, comma 3. That's the same thing. That's the same thing as saying x has to be greater than or equal to negative 2 less than or equal to 3. You can also write it x greater than or equal to negative 2 and x less than or equal to 3. This is the interval notation, and that's the type of answer I requested when I gave these kind of problems in my class, interval notation. Now I want to point out to you, if I make this less than, strictly less than, x squared minus x less than 6, the answer, the procedure would be exactly the same, except your answer will be given this way now. This would be the answer if I didn't have the equals here, if it was just strictly less than, because then when I plug in a negative 2 or a 3 for the x, I would get a 6, and 6 is equal to 6. I want it to be less than 6. Okay, so that's your solution. Now to get an idea as to why this works, okay, if I graphed the expression, okay, this is the expression that was on the left side, x squared minus x minus 6, you get an idea as to why the procedure works. If I hit graph here, notice between, there's negative 2 right there and there's 3 right there. Notice that between negative 2 and 3, the graph is below the x-axis. So the y value is negative. Okay. And to the right of 3, the graph is above. That means the y value is positive. And over here, to the left of negative 2, again the graph is to the left and above. So the y value is positive. So this is telling me that between negative 2 and 3, the expression on the left side is negative. Okay. To the right of 3, the expression is positive. To the left, it's positive. And because we want it less than, if we want it negative, that's why it works. Okay, so let's go to the second one. This one already has the right side 0. And the left side is x cubed minus 4x is greater than 0. Okay, so right side is already 0. We have to factor then the left side. We can take out an x. That leaves you with x squared minus 4 in parentheses. And then x squared minus 4 is a difference of 2 squares. So when you have the difference of 2 squares, you can factor that into the difference in the sum of the square roots. Okay, so there it is. Okay, so once you have the left side is factored out and the right side is 0, then all you want to do is find these we call critical values sometimes, and those are the numbers that produce a 0 for the left side. Okay, so if you have factors, you simply look for the number that makes each particular factor 0. So notice for x, the only way that's going to be 0 is if x is 0. For x plus 2, the only way that's going to be 0 is if x is negative 2. And for x minus 2, the only way that's going to be 0 is if x is 2. So the numbers you want to plot in the number line are x, or 0 rather, negative 2, and 2 in order of size, from on the left side from smallest to largest. So there's the number line. Okay, to the far left, the smallest number is negative 2. We plot that. And then the 0 comes next, and then the 2. So then we have 1, 2, 3, 4 intervals. So we have to find the sign of this expression right here to the left, on the left side of this inequality. Okay. So typically, once you find the sign of one of the intervals, they're going to alternate. So you'll find it could go plus, minus, or it could be minus, plus, minus, plus. But we got to find that first one. Now I say typically, there are exceptions, especially when you have one factor squared. Now if you have distinct factors like we have here, we have an x, x plus 2, x minus 2. Now if you have something like, say I had a square here, or a square over here, then that's going to prevent that from happening. So in that case, you want to check every interval. Okay, so here we go. So let's look at this. So I'm going to the right of 2, I'm just going to pick a 3. So if I put a 3 here, and all you want to know is the sign. 3 minus 2, that's positive. 3 and 2, that's positive. 3 is positive. So I have 3 positives. Each factor is positive if I pick a number to the right of 3. So that means that all I need to do here is put a plus sign here. Okay. Now, based on what I said, the next one should be negative, the next one should be positive, and then negative. Okay. But we'll go ahead and check it out. So between 0 and 2, I'm going to pick a 1. So put a 1 there, a 1 there. Both of those are positive. 1 minus 2 is a negative. So when you have a negative, multiplying 2 positives, this will be negative. Okay. Now, between negative 2 and 0, I'm going to pick a negative 1. So put a negative 1 there. That's negative. Negative 1 and 2, that's a positive. And a negative here, that's going to be a negative. Okay. So of the 3 factors, 2 of them are negative, so that's going to give me a positive here. Okay. Now, to the left of negative 2, I'm going to pick negative 3. Okay, I'll put a negative 3 here. That's a negative. Negative 3 and 2 is a negative. Negative 3 and minus 2 is a negative. So I got 3 negatives multiplied together. Well, 3 negatives multiplied together is still a negative. Okay, so the answer is given by this number line. You just simply look at the signs. What do we want? You look at the last inequality. Okay, we want this product to be greater than 0. That means positive. Okay, so you simply look at the intervals that have a positive. That would be this one and that one. Notice this does not have an equals. Okay, when you have an equals, you're going to have a bracket to indicate that the number is included. Okay, but in this case, no brackets. Okay, so it's everything between negative 2 and 0 together with everything to the right of 2. Okay. Okay. So this is your answer right here. In interval notation, everything between minus 2 and 0, that's this. Union, okay, union, so together with, and then everything to the right of 2, okay, at 2 to infinity, okay. That's including all the numbers between negative 2 and 0 together with numbers to the right of 2. Now, If this had an equals, greater than or equals, instead of just greater than, then the only difference would be that instead of parentheses, this would be a bracket. This would be a bracket. You'd have a bracket on this too also. Infinity never has a bracket, okay? It's always parentheses. That's your solution. And pretty much that procedure is going to work for any of these particular types of problems where you have polynomial expressions. Okay, just like polynomial equations, except you have the inequality instead of the equals. And the procedure again is just to make one side 0 and go through this process and check your answer. Thanks for watching. We'll see you next time.